This is the fourth and final video about the Olympic medal count analysis. And in this video, we're going to talk about correlation, and more specifically, the correlation coefficient. And before we get into the actual calculation of this, I'm going to switch to a slide that does a really good job of explaining correlation and the correlation coefficient. So here we have a whole bunch of scatter plots. And the first thing to notice is the difference between the left and the right side. We have positive correlations on the left and negative correlations on the right. And what that generally refers to is the direction or the slope of this correlation. Notice right here that as the independent variable increases, the dependent variable also increases. So this line would have a positive slope, and so it is positively correlated. A negative correlation means that as the independent variable increases, then the dependent variable decreases. So this line is going down. So things that generally trend in the upward direction from left to right are positively correlated, and scatter plots that tend to move in the negative direction are negatively correlated. You also might notice that as you go down the chart from top to bottom, you see the points, they fall out of a perfect line and they become more and more scattered. And so what we're seeing from top to bottom is the strength of the correlation. And they've used some words to describe how strong the correlation really is. Well, when we're here at the very top and our points fall exactly in a line, we say that is a perfect correlation. And so this is a perfect positive correlation, and this is a perfect negative correlation. And, you know, this is pretty strong right here. They say very strong. So the points are not in a perfectly straight line, but they are very close to a straight line. And so that is an indication of a very strong correlation, either positive or negative. And as we go down, you know, this is still pretty strong, and then maybe moderate. You can still look at this scatter plot and see that there's generally a linear trend that is happening with this data. But then you get into these lower regions and the correlation is very weak, and eventually there's just no correlation. These points are kind of randomly sort of strewn about the field here, the coordinate plane. So when we talk about correlation, when we describe correlation, we describe whether it's positive or negative, and we describe how strong or the strength of the correlation. If the points fall perfectly on a line, that is a perfect or very strong correlation, and then it can get weaker and weaker. And then R in these yellow boxes is the correlation coefficient. It's actually a number that you can calculate, and we're not going to get into the details of how you calculate this number in this video series, but you just notice that the correlation coefficient is a way of mathematically determining this correlation, and depending on the value of R, we can attach certain qualifiers, you know, strong, weak, positive, negative, and so on. So the sign of the correlation coefficient will tell you whether it's a positive or a negative correlation. And then the actual value, which could range anywhere from +1 all the way to 0, where there's no correlation, and then all the way down to -1, which is a perfect negative correlation. But the value of that, the actual magnitude of that number, tells us how strong or weak the correlation is. So if we take this information over to our medal count spreadsheet, we might look and see, like, well, you know, there is a linear trend here for sure, especially when we get out to these outliers. It's hard to tell what's going on down here because of our scale. But but there is some correlation happening here, and may or may not be very strong, maybe moderate. But we can actually do the calculation and get the correlation coefficient here by using a formula. And the formula, you probably figured out already, is called CORREL. It just is a shortened version of correlation. So we're going to use the correlation function in the spreadsheet, and just as we did before, we're going to give it all of our Y data, and then we're going to give it all of our X data. And again, I'm going to limit the precision of this calculation so that it's a little more legible. And we get a correlation coefficient of 0.85. It's positive, which you might have guessed by just looking at the line here. And to be honest, that number is a little bit higher than I expected based on how this data is spread out. But let's go back to our slide and see what a correlation coefficient of 0.85 means. We would locate that, somewhere around here, moderate. So according to the correlation coefficient that we calculated, we have a moderate positive correlation. And the last question that you have down here, describe the correlation between the factor that you're exploring, GDP, and the metal count. And so you can describe whether it's positive, zero, negative, strong, or weak, or no correlation right here. I gave you some sentence starters or some scaffolding here to language to use, but you can also get it from the slide. So the last thing I would say about correlation coefficient is that it doesn't have units. It's a unitless quantity, so we're not going to put any units here. But we have a moderate positive correlation between a country's GDP and the number of medals that they won in the 2012 Olympics. So once you've composed statements for each of these questions, you're pretty much done with this page. And the rest of this assignment involves copying this template and doing the same analysis that we just did, but with different information: area, population, GDP per capita, life expectancy, and population growth. So you can make another copy or duplicate this this sheet, and just as we did in the first video, and copy data, other sets of data, and figure out if there is a correlation or how strongly correlated these demographic are with the medal count. So to complete this assignment, you're going to do the same analysis that we did here and answer the same questions that we did, but for each of these other statistics: area, population, per capita GDP, life expectancy, and population growth.